Hey. Hello everyone, in the world of Blenderizm. Glad to meet you all again, boys and girls. I want to say a special hello to Blenderizm fans from Vietnam. As analytics show, the Vietnamese like my work the most. So if you are a representative of this wonderful sunny country, like in support of Blenderizm, write in the comments what you like or what you would like to see, and I thank you for the future. Cam on kak ban, en hung nuoi dang ky qua toi. So, I did a little analytics and noticed that there is no step-by-step instruction on how to create a Mercedes-Benz K500 Roadster on YouTube. This is a sports car produced by Mercedes-Benz from 1934 to 1936. And I just like the way it looks, so I decided to make a 3D model of this car. In order to have enough information and references, I spent a little time on Google. I downloaded images of our Roadster from different angles, drawings, and even downloaded a video in good quality so that I could see small details that are not always visible in the photo. If I describe it briefly, then in this issue I want to show you the creation of a block model of a car, that is, roughly speaking, a frame or body of a car. This is the first part of this project. Some people may find it boring. But this is part of the process, which you also need to be able to do and understand how it happens. In this issue you will see the principles of creation, the sequence of actions, what modifiers will help us in this work. The creation of a 3D scene needs at least 3 key components: models, materials and lights. In this part, the first of these is covered, that being modeling. Modeling is simply the art and science of creating a surface that either mimics the shape of a real-world object or expresses your imagination of abstract objects. Depending on the type of object you are trying to model, there are different types of modeling modes. Since modes are not specific to modeling, they are covered in different parts of the manual. Switching between modes while modeling is common. Some tools may be available in more than one mode while others may be unique to a particular mode. Edit mode is the main mode where modeling takes place. Edit mode is used to edit the following types of objects: meshes, curves, surfaces, metaballs, text objects, lattice. You can only modify the mesh of the objects you are editing. To modify other objects you can leave edit mode, select another object and enter edit mode, or use multi-object editing. How to create a 3D model from a photo. A special term was invented for making 3D photos, photogrammetry. This type of modeling is now widely used in architecture, art and even in industry. Many movie characters and computer game heroes are created using this method. Photogrammetry is usually used in 2 cases, either when it is not possible to create a 3D model from drawings, or when it comes to a particularly large object. This method is well suited to create a 3D model of a car, building or other large-sized object. 3D model, features of creation from photos, drawings and real prototypes. To create a 3D model from a photo, you do not need to know the exact real dimensions of the object. Creating a 3D photo is especially relevant in cases where a person does not have the opportunity to visit the object. For example, it is too far away or visiting it can be dangerous to life and health. Just like for other types of modeling, special equipment is used for photogrammetry. To get the highest quality 3D model from a photo, you need to prepare at least 3 pictures of the object, from the side, from the front and from above. In this case, to create a 3D model from a photo, all 3 pictures must be the same size. If we are talking about a person, an animal or any other living object, for 3D from a photo you can additionally prepare a picture in semi-profile. As in the case of working with drawings, it is very important to take into account all the existing nuances. This will improve the quality of the finished 3D model from a photo. There are several advantages to using 3D models in the automotive industry. Firstly, 3D modeling can significantly reduce the time and cost of developing new car models. Secondly, 3D models provide a more accurate representation of the appearance and characteristics of the car, which allows manufacturers to better control the production process. Thirdly, 3D modeling makes it possible to optimize the process of developing and producing a car, minimizing risks and possible errors. 3D modeling provides greater flexibility in the car development process. It allows designers and engineers to quickly make changes and adjustments to the model, which can be especially useful when developing new technologies or changing market requirements. 3D modeling can be used to create virtual tests of cars. This allows manufacturers to test new models without the need to create physical prototypes, which reduces costs and development time. Finally, 3D modeling can help the automotive industry become more sustainable and environmentally responsible. Using 3D technology, manufacturers can create more efficient and economical cars that will have a smaller impact on the environment. In conclusion, 3D modeling is an integral part of modern automotive design and production. The use of 3D technologies allows us to create better and more efficient cars, and also reduces the time and costs of their development. The future of the automobile industry is closely linked to the development of 3D modeling and the use of new technologies in this area. Photogrammetry also has its drawbacks. For example, the internal structure of an object will have to be additionally modeled, since in most cases it cannot be conveyed using a photo. For this, a special program for creating a 3D model from a photo is used. There may also be a need for additional technical development of other details if you are creating a 3D model from a photo. In addition, it is important to understand that you need to approach the issue of preparing photos very carefully. If they are of poor quality, the modeling result will be corresponding. In general, generating 3D models from photos allows you to achieve good results. 3D scanning. What is the difference to create a 3D model using this method? A special 3D scanner is used. It differs from 3D printers in the type of its design. Scanning is only possible if you have a real prototype, the 3D model of which you plan to create. In this case, it must be close to the scanner. There are two types of scanning, contact and non-contact. The first one is quite simple. During direct contact with the object, the equipment records its parameters and creates a volumetric 3D model. The second method is a little more complicated. It is divided into two types: active, special waves, X-rays, light, ultrasound, are directed at the object, and then the scanner records their reflection. Passive, the device records the reflection of natural radiation. There is no direction of special waves. All types of scanning demonstrate equally good results. As a rule, it is impossible to notice a significant difference in the quality of the object. When choosing a 3D scanner, pay attention to the conditions in which you plan to work. For example, is it possible to gain direct access to the object, or will you have to scan from a distance? Is natural light available in the room? 3D scanning is often used in cases where it is necessary to create a high-quality copy of some part. This allows you not to make it again, but simply recreate it using a special device. Most scanners can be used for objects from 1 cm in size. The maximum size depends on the specific model. How to make a 3D model based on a real object. This type of 3D modeling is less popular than others. Quite often used in cases where it is a question of working with real objects, a 3D scanner is used. If for some reason this is impossible, for example, at the moment there is no such equipment, then 3D modeling is used. The specialist who performs the work moves the object in such a way as to create a 3D model as accurately as possible. This method is best suited for small objects that move easily. If possible, the object is even disassembled into individual components. 3D model, features of creation from photos, drawings and real prototypes. In the modern world, 3D modeling has become a new trend. It is widely used in various industries. Fine arts, architecture, cinema, advertising, when developing an advertising character, logo. In addition, with the help of 3D models, you can solve everyday problems. Creating many objects has become much easier. If desired, anyone can understand how to make a 3D model. A special program for creating a 3D model from a photograph or drawing is quite easy to use. At the same time, to achieve the desired result, relatively little is required: a prototype, in the form of a drawing, photograph or real object, special equipment and the necessary software. The method of modeling using drawings is considered the simplest. Drawings for 3D modeling are special design documentation that contains all the necessary information about the object. At the same time, the data is presented in sufficient detail, all the necessary nuances are indicated. The drawing must contain the following data about the object: design features, dimensions, parameters, materials. It is important to understand that one-sided drawings are not suitable for 3D modeling. The design documentation must contain clear information about at least 3 sides of the object: front, top, side. Otherwise, it will not be possible to recreate the object as realistically as possible. If you are working on creating a 3D model from a drawing or planning to order its production in a specialized center, you should pay attention to all the details that the prototype has. You can familiarize yourself with the method of its production, features of use, individual fragments. The more information you learn, the higher the guarantee that the 3D model will be identical to the original. 6 tips for modeling with mesh subdivision. Here are some tips for modeling objects using the subdivision surface modifier. 1. Always start with building a block model. Creating a block model is one of the most important stages of modeling. At this stage, you determine the scale, style, and appearance of your model. That is why you should always start with a base shape. If you start adding a lot of details, then changing the further shape of the mesh will be quite problematic. 2. Use as few polygons as possible. When you subdivide a mesh with the subdivision surface modifier, you don't have to worry about sharp corners in your object anymore, because they will all be smoothed out. In the end, no one will see the original low-poly model. Do you really need to use a cylinder with 32 edges, or can you get by with 6 by adding the subdivision surface modifier to level 2? Keep your models as simple as possible. If the polygons don't serve a specific purpose, they should probably be removed. 3. Tris and n-gons aren't always bad. Triangles and n-gons have a pretty nasty reputation for ruining the topology of an object in many cases, but if used in the right circumstances, they can be useful. They will eventually be converted to quads anyway. Just don't take this as permission to use triangles and polygons anywhere, because they don't have a bad reputation for nothing, but in some cases they can be preferable to quadrilaterals. 4. Keep quadrilaterals square. You've probably heard this rule many times, but there are still a lot of models where quadrilaterals are rectangular. This is one of the fundamental rules that should be followed when modeling. Following this rule will make your model smoother, and also avoid various problems when creating UV unwrapping. 5. Model with modifiers. Modifiers do not change the topology of your objects. You can turn them on, off at any time without any consequences for the original mesh. Using modifiers instead of directly changing the topology is much preferable and will save you many hours of time. 6. Use creases on small or remote objects. Instead of adding additional edges to give rigidity to certain parts of the mesh, use the crease tool. This will keep the polygon count on your object low and simple. As the title says, use this technique on small objects or those that are far from the camera, mesh or grid. These terms are called a set of vertices, edges, and polygons that make up one 3D object. The word mesh comes from the English mesh, a network cell. And the word grid, from the English wireframe, which is translated as a frame/wireframe. I also sometimes use the term geometry, which essentially means the same thing as mesh. The thing is that the word geometry is also translated from English as form. Examples of usage: need to transfer the glove mesh to ZBrush, means that you need to take your 3D glove model and export, transfer it to the ZBrush sculpting package. To add realism, you need to bend this mesh, means that you need to drag, move, the vertices, or edges, or polygons, on the 3D object a little in a chaotic manner so that it no longer looks perfectly straight. The main picture shows the glove mesh. This means that the picture shows not only the 3D model of the glove, but also its wireframe, i.e. those white lines that show how and which polygons, square, rectangular, consisting of 4 sides or 3, form the glove. Topology is how exactly the polygons formed the 3D model. The picture below shows, above, 2 3D models of gloves, and their mesh is shown below them. Correct topology serves 2 purposes: correct deformations during animation, use of a minimum number of polygons to describe the desired shape. In this case, the polygons should be located on the 3D model, usually, a living creature, so that when bones or muscles move, it is easy to repeat the real bulges of these same muscles or bones. The simplest example is the need to compact the mesh on the knees and elbows. After all, when we model a character in a T-pose, the elbows and knees are straight. But when they need to be bent at 90 degrees, it turns out that there are not enough polygons, if the modeler made the mesh uniform, to form a beautiful rounding of the elbow or knee. In another case, having the skill of low-poly modeling, you will be able to use each polygon very effectively, which means the model will be lightweight, have few polygons. This is especially appreciated in game engines. After all, resources are always limited, or for animation. So in our case, I try to make Mercedes as less polygonal as possible. Since the previous model that I made, Lamborghini Huracan, had about 1.5 million polygons. And I haven't modeled the interior yet. Retopology literally means to make the topology again, anew. Usually, retopology is done on the basis of a high poly, 3D model, for example, first in ZBrush, or in Mudbox, or 3D Coat, you sculpt a detailed 3D model of a gnome, completely ignoring the topology and density of the mesh. Then, you need to animate this gnome. But making a gnome react quickly to 30 million polygons in the Maya, or 3ds Max, or Blender, viewport is an impossible task. Therefore, this gnome is retopologized. That is, based on the already finished high polygon form, a low polygon mesh of the gnome is created, which is very convenient and easy to animate. And all those details from the high polygon version are transferred to the low polygon one using various techniques, for example, using displacement or normal maps. Sometimes, they use the abbreviated spelling, retopo. Modifiers are automatic operations that affect an object's geometry in a non-destructive way. With modifiers, you can automatically perform many effects that would otherwise be too tedious to do manually, like subdivision surfaces, and without affecting the underlying geometry of your object. They work by changing the way an object displays and renders, but not the geometry, which you can edit directly. You can add multiple modifiers to a single object to form a modifier stack, and apply a modifier if you want to make its changes permanent. They can be added to the active object using the Add Modifier operator, the Add Modifier button at the top of Modifiers tab in the Properties, or using Shift-A in the same tab. New modifiers are always added at the bottom of the stack. There are many built-in modifiers, but Blender also allows users to make their own modifiers through geometry nodes. In this tutorial we will use modifiers such as Subdivision Surface. The Subdivision Surface modifier, often shortened to Subdiv, is used to split the faces of a mesh into smaller faces, giving it a smooth appearance. It enables you to create complex smooth surfaces while modeling simple, low-vertex meshes. It avoids the need to save and maintain huge amounts of data, and gives a smooth organic look to the object. The Subdivision Surface modifier does not allow you to edit the new subdivided geometry without applying it, but the Multi-Resolution modifier does. As with any modifier, the order of execution, position in the modifier stack, has an important bearing on the results. Keep in mind that this is a different operation than its companion, smooth shading. Bevel. The modifier smooths the edges of the mesh it is applied to, with some control over how and where the bevel is applied to the mesh. The Solidify modifier takes the surface of any mesh and adds depth, thickness to it. The Boolean modifier. The modifier performs mesh operations that are otherwise too complex to accomplish in just a few steps by manually editing the meshes. It uses one of 3 available Boolean operations to create one grid from 2. Mirror modifier. The modifier mirrors the mesh along its local x, y, and or z axis relative to the origin of the object. It can also use another object as the center of symmetry, and then use that object's local axis instead of its own. Wireframe modifier. The wireframe modifier transforms a mesh into a wireframe by iterating over its faces, collecting all edges and turning those edges into 4-sided polygons. Be aware of the fact that your mesh needs to have faces to be wireframed. You can define the thickness, the material and several other parameters of the generated wireframe dynamically via the given modifier options. If you look at it from a very professional point of view, Blender is not suitable for modeling cars. For example, imagine your UV sphere. It consists of polygons. And no matter how many times you subdivide it, it will not become round, the polygons will just become very small and invisible to the eye. So then another thing you know in Blender is, there's smooth shading, but the problem is smooth shading doesn't work in the real world, it's fake. So this also won't work, if you actually want to produce what you designed. So that's the main issue in Blender. So, the next thing is you could use curves. You know how curves are quite round and you can also make them rounder and they seem infinitely round. Because you can move them around and they're almost the right thing, but the problem is, they're really so based on polygons in a Blender or on vertices or in faces or in edges, they're never perfectly round, they're just gonna seem round, and you can't send this to a factory. Like this just won't work, they need a different type of file. So now you're probably asking yourself, okay, what software should you use? And luckily it's not 3ds Max, it's not Maya, because those are also polygon tools, so they're basically the same as Blender, but just by a different company. There's one different type of 3D that is used for all cars and basically everything that is actually built in the real world, and it's called CAD modeling. Blender doesn't support CAD modeling. Actually Maya and 3ds Max also don't support CAD modeling, Cinema 4D doesn't support CAD modeling, probably all softwares you know don't support CAD modeling, because this is a completely different type of 3D. CAD is also based on Boolean. So in Blender you usually don't use Booleans, because they mess up your mesh and just make stuff ugly. You do clean topology, clean modeling. In CAD it's kind of the opposite, you're just going to bool everything, and if you start looking at real products and then look at CAD you're going to notice why these products look this way, because often you see these techniques they use in CAD that end up in real products. So things sometimes are hard to model in Blender, because they're based on pretty cool features that CAD usually just has. So I don't know if you remember, in math you had like a curve on a graph and you could always calculate the point on X or the point on Y, and you could calculate it perfectly in any spot, like it was infinitely smooth basically, and that's how CAD works, and that's how factories work. That's how these big machines work, they need CAD to get controlled. So you could use Blender like in a 3D printer where things aren't that smooth, it would also look fine, but if you would make a car or something you would need more professional soft. So you see, everything has its use case, like one isn't better than the other, just one thing is better for this stuff and the other thing is better for this stuff. So it's also the same thing with Blender. So the thing is also in Blender. You've seen cars I use in Blender. Now you, maybe also, ask yourself, why do I even use Blender, if CAD is so great? Because the reason why is Blender is for rendering mainly in animation and stuff like that, and not for modeling professional cars. So for example, if you're also working on car games, they need optimized models. So you can remodel cars and you can make them low poly, you can bake stuff over and then they're performant and run in games, but the thing is also. So if you want to learn from scratch modeling, from blueprints, if you're working for a big games company, they can't just use cars. So they're definitely in contact with brands, and these brands have all cars, because they're already built. And if they're in contact with rims from certain companies, they already have the rims in CAD, because that's what they give their machines, to produce these rims, so if the parts don't exist in the real world, you would probably have to make them yourself. But these car games usually have real parts, real brands, and I'm gonna guarantee you every single part is already made in 3D, every screw, every hole already exists in 3D, otherwise this thing wouldn't exist. So there's actually, almost never, a scenario where you would have to model anything in the real world that's about cars except the environment. The roads and stuff. So what I'm trying to say, is you're probably never gonna have to model a car ever, unless you're working for a games company, but they're probably gonna give you the car and you just have to remodel it. So you have a perfect example role model. I am talking about big companies. I didn't want to scare you, supposedly Blender is not suitable for modeling, it's just that there is another side of the coin that I wanted to share with you. In general, for training in hard surface modeling, creating cars is very good. In order to hone your skills. In order to understand how to use modifiers. When it comes to 3D modeling, there are two types, hard surface modeling and organic modeling. Both are used to create 3D objects using the same type of polygons, a similar mesh, and almost the same software. The fine line between hard surface and organic, defined by different modelers, is what makes it difficult to understand. One is more appropriate for 3D visualization, while the other is extensively used in animation. What is organic modeling? The things that organic modeling covers range from people and animals to trees, plants, and other organic objects. Typically, these are living things. Therefore, animated objects are also considered organic, although they can be man-made. However, we will come to this later. Usually, organic models are built from full quads, four-sided polygons. This helps to avoid deformation during the rendering and animation stages. So, the shape does not matter much as long as the number of sides is 4, unlike hard surface modeling. At the same time, the use of n-gons, polygons with 5 sides or more, is not recommended at all. Even though a 3D object has already been created in a polygonal 3D modeling program, it does not mean that it is finished. To add finer details and produce more real-life models, an object is imported into sculpting software like ZBrush. Only then does it get the realistic shade needed to live up to expectations. However, to master organic modeling, you must study a lot of reference images and study the anatomy of living creatures in order to bring them to life in a digital environment. What is hard surface modeling? Hard surface modeling is a 3D modeling technique used to recreate inanimate objects with smooth, static surfaces in three-dimensional space. It is widely used in science fiction and shooter video games to create weapons, robots, armor, cars, and structures. Given the description of organic modeling, you should have no difficulty in determining what hard surface modeling is. It is the modeling of man-made objects that do not contain curves or smooth edges. In general, it covers all inorganic and non-living objects such as cars, buildings, computers, furniture, and any other static machined objects. The first thing that differentiates hard surface modeling from organic modeling is the type of polygons used. The latter requires the model to consist of complete quadrants. You already know that, however, hard surface modeling is much more moderate in this matter. The number of sides in a polygon does not matter much, as long as the result is satisfactory. Hard surface modeling is the preferred way for beginners to learn how to make a 3D model. Creating plain flat edges is generally simpler than complex detail-oriented models. That's why it is the best way to learn how to operate 3D modeling software and cover the basics. However, you will need to have some images and drawings to refer to if you want to master hard surface modeling skills. I hope you enjoyed this lesson. Further, we will create parts of the Mercedes K500 Roadster, such as moldings, glass, grills, different pipes, logos, handles, and so on. If you liked it and you want to support the channel, then don't forget to check the subscription, write a comment and like from the heart. Well, as always, learn hotkeys, they will make your life easier. Take your time, try different settings and pray for Ukraine. Thanks, bye.